Hello friends and welcome to the Statisticians. In this video, I will try to clear your idea about p-value, what actually it represents with a real life example, and why we use a benchmark of 0.05. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use statistical software to analyze data, one of the key outputs is the p-value. In formal terms, the p-value is the probability that if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis is true. We will now go through this concept step by step with a real life example. A certain prescription allergy medicine is supposed to contain an average of 245 parts per million of a certain chemical. If the concentration is higher than 245 ppm, the drug will likely cause unpleasant side effects, and if the concentration is below 245, the drug may be ineffective. The manufacturer wants to check whether the mean concentration in a large shipment is the required 245 or not. The manufacturer can't open up all the shipment to check, as then they would not be able to sell it. So he decided to hire a statistician for a statistical test. On a randomly chosen sample from the shipment, the null hypothesis, often called H0, is the thing we are trying to provide evidence against. For the statistician, the null hypothesis is that the average of 245 parts per million of a certain chemical as it should be. The alternative hypothesis H1 or HA is what we are trying to prove. The manufacturer suspected that the average is different from 245. The statistician decided to use a significance level of 0.05. If the p-value is lower than this, he will reject the null hypothesis. He took a random sample of 60 portions from large shipment. If all the values were lower than 245 with a mean of 220 grams, for instance, it will be quite obvious that the shipment did not have the required amount of chemical. It is very unlikely that you will get 60 sample values with a mean of 220 ppm. If the overall mean of the shipment in the population is 245. Conversely, if all the 60 sample values were much bigger than 245, it would be obvious that there were more amount of chemical in the shipment. However, in this case, the 60 sample values have a mean of 250 ppm with a standard deviation of 20. The statistical software R is used to find the results, and the statistician got a p-value of 0.0576. Judging from the data that we have, there is almost 6% chance of getting a mean as different if the null hypothesis is true and the mean amount of chemical is 245. This p-value of 0.0576 does not provide enough evidence to reject the null hypothesis. In this case, the manufacturer does not have evidence to say that the amount of chemical is different from 245 ppm. This is relief. The smaller the p-value is, the less likely it is that the result we got was simply a result of luck. If the p-value had turned out to be very small, we then would say that the result was significantly different from 245. In general, we start by saying that the null hypothesis is true. We take a sample and get a statistic. We work out how likely it is to get a statistic like this. If the null hypothesis is true, this is the p-value. If the p-value is very small, then our original idea must have been wrong. So we reject the null hypothesis. It is a very simple rule that if p is low, null must go. A small p-value indicates a significant result. The smaller the p-value is, the more evidence we have that the null hypothesis is probably wrong. If the p-value is large, then our original idea is probably correct. We do not reject the null hypothesis. This is called a non-significant result. The p-value tells us whether we have evidence from the sample that there is an effect in the population. A p-value less than 0.05 means that we have evidence of an effect. A p-value of more than 0.05 means that there is no evidence of an effect. Sometimes a significance level different from 0.05, but 0.05 is the most common one. But how much evidence do you need to do that? That's where the p-value is less than 0.05 comes in. I'm not going to get deep into the statistical distribution of all this, bringing back that p is less than 0.05 idea. Basically that says that the convention that many scientific disciplines follow is that to have enough evidence to reject a null hypothesis, your results need to be no more than 5% unlikely if the null hypothesis is actually true. Any more than that and we say we don't have enough evidence to reject the null hypothesis, and any less than that and we say that we do have enough evidence to reject the null hypothesis. Now why? Why 0.05? Why is that cut off for whether something is statistically significant or not? Why not 0.15 or 0.03? The answer is actually very simple. It's totally arbitrary. Ronald A. Fisher in the early 20th century suggested that 5% benchmark, and we have stuck with it. Since there is really no good reason for 5% to be the cutoff for statistical significance, it's just a convention. If you want to be sure that your evidence is very strong in its ability to reject the null hypothesis, pick a smaller cutoff like 0.01. If you don't care as much about strong evidence, pick a higher value like 0.15. It actually doesn't matter. It's totally depend on the type of experiment and the choice of the researcher according to the need of study. But remember that p-value is a detective, not a judge. If you do an experiment and find a result that is statistically significant, that is telling you that is an interesting place to look and research for and understand further what's going on. Please, it doesn't mean don't study anymore because the matter is settled. Dear friends, if you like our videos, please take a moment to like this video, subscribe to this channel and click that little bell icon so you don't miss out any new video. If you have any question, you can ask in the comment box. Thank you very much for watching our videos.